Section 1.7 is logical reasoning. So we're going to talk today about something called a conditional statement, often also called an if-then statement. If A, then B. So let's talk about what that means. A is our hypothesis. B is our conclusion. So you're going to need to know the difference between a hypothesis and a conclusion. So write that down, and then we'll do one that'll make a little more sense. So if I have a statement like this, if the plant dies, then it wasn't properly cared for. This is an if-then or a conditional statement. If something happens, then something else. So if the plant dies, this is my hypothesis. Sorry, my pen's not working very well. This is my hypothesis. If the plant dies, it wasn't properly cared for is the conclusion that I make. So if you see a plant that has died, you can hypothesize that the conclusion of that is that somebody didn't take care of it, didn't water it, didn't feed it, something. So let's look at a few statements and see if we can identify the hypothesis and the conclusion. If it is Friday, then Madison and Mark are going to the beach. So apparently every Friday they go to the beach. So the hypothesis is it is Friday. The conclusion is that Madison and Mark are going to the beach. If 4x plus 3 is greater than 27, my hypothesis, then x is greater than 6 is my conclusion. So write down, copy these down, and copy down what's the hypothesis and what's the conclusion. Make sure you get all this in your notes. Okay, copy down this one, and then you figure out the hypothesis and the conclusion. So I assume that you paused and wrote. Don't just keep going on. So the hypothesis is you got an A on Mrs. Geating's quiz. The conclusion, you understood the material. So that's the hypothesis and the conclusion. So let's look at this a little bit further. If-then statements. How can I change a regular statement to an if-then or conditional form of the statement? So here's a regular statement. I will go to the movies with you on Saturday. Copy that down. Pause if you need to. So we want to write a conditional. So I'm going to say, and again, sometimes you have to switch the order around. If it is Saturday, then I will go to the movies. With you. Hypothesis, it is Saturday. Conclusion, I will go to the movies with you. Could we write this one the other way? If I go to the movies with you, then it is Saturday. Is that just as good? Pause for a moment, look at the original statement, and see if I can write my conditional form either way or whether this is the only correct way to write it. So I say that this second way is not a conditional for the original statement. It says, I will go to the movies with you on Saturday. It doesn't say that's the only day I will go to the movies with you. Just because I'm going to go to the movies with you on Saturday doesn't mean that I might not go to the movies with you on Tuesday. So if I go to the movies with you, I don't automatically know that it is Saturday. Okay? But if it is Saturday, then I am definitely going to the movies with you. So this is not a conditional for the original statement. Whoops. For a number x such that x minus, or 6x minus 8 equals 16, x equals 4, write a conditional for me. So if 6x minus 8 equals 16, then x must equal 4. Hypothesis, conclusion. And again, if I wrote it the other way, if x equals 4, then 6x minus 8 equals 16. Maybe, but there are lots of other things that could be the same. So watch your order. Deductive reasoning. Take a moment and write all this down, and then we'll talk about it. Okay, given a true conditional, something that is true, there are some conditionals that may not be true. For example, if I said, if you got an A on my quiz, then you are good in French. That's not necessarily a true conditional. So given a true conditional and a hypothesis for another given case, I'm going to put for another, okay, given case is true. And you'll see what that means in a minute. Then deductive reasoning allows you to say that the conclusion is also true for that case, and you can make a valid conclusion. So let's find, first of all, a true conditional. A true conditional statement. If two numbers are odd, hypothesis, then their sum is even, conclusion. Any two odd numbers added together will make an even number. Now, if I can find a hypothesis, the same hypothesis, two numbers are odd, for a particular given case, in other words, pick two odd numbers. If two numbers are 7 and 3, are they both odd? Is this true? Is this hypothesis the same as this? Yes. So, two numbers are 7 and 3. Can you make a valid conclusion? Can you say, then their sum is even? Yes. So, this conditional statement is true. I find another case that is the same as this hypothesis, two odd numbers, and therefore by deductive reasoning, I can conclude that their sum is even. This statement is true. Two odd numbers are odd. Their sum is even. I found two odd numbers, and I can conclude that their sum is even. The sum of two numbers is 14. Now, this says that a sum is even. Can I conclude that the two numbers are odd? In this case, no, because this is not a hypothesis. This matches the conclusion. So I cannot do this in reverse. I need a matching hypothesis in order to conclude that the conclusion is true. Because we can think of lots of two numbers that add together to 14 that are not both odd. I can say 10 and 4, I can say 12 and 2, etc., etc. So I need a hypothesis that is the same as the given hypothesis, then I can make a valid conclusion. Counterexamples. One way to prove a conditional statement as false is to give a counterexample. It's one example that can prove that the conditional, or the if-then statement, is false. So, here's my conditional statement. If you are using the internet, hypothesis, then you own a computer, conclusion. Is that always true? Is a hypothesis of somebody using the internet, can you conclude that they own a computer? Can you think of a counterexample? So my counterexample is that you're using a computer in the library. Another counterexample might be that you're borrowing a friend's computer. So there are lots of ways that you can use the internet without actually owning a computer. Maybe you're using your iPhone and you don't own a computer. Okay, so lots of different ways that we can prove by a counterexample, one example that would prove this false. So, if the commutative property is true for multiplication, then it is true for division. So I need a counterexample. So the commutative property is true for multiplication. I need an example of that would then show that it is not true for division. So 3 times 2 equals 2 times 3. That's the commutative property. It is true for multiplication. If I take that same example, is 3 divided by 2 equal to 2 divided by 3? No, it is not. So there's my counterexample that proves that this conditional is false. Okay? And that is it for the video. We'll talk about this in class.